Hello, and welcome back to Monroe Live. My name is Carl, and we have Scott back again with us.
Hey.
So we have disassembled and removed the instrument panel from the Rivian, and we're going to review what we see here. We, of course, have not completely torn it apart, but we wanted to kind of give a first impression of the IP itself. Now, I don't know about you, but when I look at this, I see, from stepping back, it does look like a high-end interior, a high-end instrument panel.
Yeah, I mean, I think one of the things too that jumps out, you see some of the material choices, some of the juxtaposition of different textures and feels, the things that jump out that are maybe not super typical, like you've got the wood grain, you've got like a more fibrous element, and you've got kind of like a, I don't know, like a satin chrome with like a little bit more of like a gold hue to it. So, I mean, wood textures in vehicles, you see that. I know, Carl, you're excited to talk more about that wood specifically. But yeah, just like, I think mixing up, like you've got sort of like a shiny surface, you've got a grain surface, you've got like a textured textile surface, good sort of variety. Definitely they're paying a premium for some of these materials. Aesthetically pleasing. Obviously we'll look into some of the different manufacturing considerations for that, but I'd agree with you. I think it's a handsome instrument panel. And I think, do they have different wood grain options for the different?
I'm not sure of the different options myself. Yep. So with the wood, I do like the wood. I like having a matte finish wood. I like having the amount that they put here. However, the problems with this wood, I mostly blame the studio designer. I don't blame the engineer. I don't blame the people that had to put it together. So one of the things that I did not point out in my last video is this corner. So whenever you have an outside corner of any type of a sheet stock material, you have to have a fold. We would normally call that like tableclothing. If you're putting a tablecloth on the corner of a table, you have a lot of excess material. So what they had to do to cut out that excess material, there's an A-surface cut on both sides right in front of the driver. It almost seems like it's a very unfortunate situation to have right there in front of the driver. Now, if they would have kept that flat and not created that recessed curve, they would not have had that.
That's true. Now, it is worth mentioning, as it sits right now, we've got the top cover kind of loosely situated above here. Normally, this is flush, so this isn't quite as visible, but I know, Carl, you did confirm it is visible. We've just got it kind of loosely installed because it's a little bit of a pain to pop off. But we'll, maybe to give you guys a better view, we'll take this top cover off and kind of zoom in, and Carl can talk about kind of some of the manufacturing considerations as this part is actually made with those cuts that I'll agree. Now that you've pointed out, I can't unsee those. Like, they're pretty rough.
Yeah, so they have basically an in-mold material that is back injected. That flat material has to fit into that not flat, convex, concave, multifaceted shape. Yeah. And a very, very thin wood fiber just will not do that on its own. So you do have to cut in order to make it match that surface.
Yeah, and so when Carl says like it's a backfilled injection mold, this film, they're actually having to place that in the tool and shoot that soft resin behind it before it cures and makes the final part. So if you can imagine, you've got this cut, this little kind of bird's beak here, and not only is that having to be precision cut, but someone has to manually put that into the tool, fit it, hold it, so that the tool can close and then shoot behind it. And I mean, obviously your fingers can't be in there to hold it. Carl, is it like, how do they hold that in place when they shoot that?
The tooling will all do that once they figure it out. So that's why when you build a tool, you have to be very, very specific. There are many different resins that you can put into an injection mold. ABS, polypropylene, nylon, but you actually have to build your tool specific to the resin. So every resin has its own shrink rate. So if I'm trying to injection mold something as polypropylene and I say, nah, polypropylene's bad, let's switch to ABS. It's going to shrink differently, which means all of these attachment positions will be in a slightly different position. So not only did they have to calculate for the shrink rate of the resin, but they had to deal with the wood, which may or may not shrink. So you really have to think very far in advance about what you want to do before you even build the tool.
Yeah. And I think that's your point, right? Is that the depth of this, probably they had the idea for the wood grain look long in advance of when they actually had their surfaces finalized and actually started trying to design tooling. And at the end of the day, they had to make some compromises. Again, most people, maybe they wouldn't see it. It is sort of hidden by the overhang of the top cover. But yeah, just some considerations, things you might, thinking farther out in advance, definitely. I think the more reps of building vehicles that you get, the more people kind of understand that you got to take that into consideration.
So the wrapped top pad, I honestly want to commend them on this wrapped top pad. It's an artificial material, yes, but the complexity is where this was very, very well thought out. So from the other video that we did on the Rivian, we talked about fixed positions of wrapping. Each of these 4 corners are a fixed position. Because that is actually sewn into the cover, that corner of the sewn cover must be positioned at that point of the curve of the instrument panel. However, this entire length can stretch. So if this cover is slightly too large, I can pull out all of my wrinkles to the end of the part. Now, with that, look at the very end. There is no side face. That seam is pulled out and then wrapped right over the edge. This is why I am commending them on this. This system, this setup, can be automated. I could get this at a very, very low cost. The only thing the operator would have to do is set the upper seam. All of the edge fold and all of the pressing could be done automatically. Now let's compare that to the Model S. In general, I would commend the Model S of doing a good job. However, they made the mistake of having a side face. See this sewn seam? This sewn seam and that corner are now fixed positions. There's one on each side of the IP. So if we were wrapping this IP, I have my fixed position curves, but now the entire outside length is a fixed position. I have no ability for tolerance. This pattern must be made purposely smaller and then stretched to get the corners where they need to be. That whole stretch operation has to be done by hand. This would be more labor intensive than the design that Rivian came up with.
Good points. Yeah, essentially, yeah, if you're familiar with dimensioning or whatever, like that design has more constraints. You're fully constrained at multiple points and you're gonna have to fight all of that stretch to get it to lay perfectly. With this, you've given yourself some reprieve, you have some fixed points in the middle, and you have some slack on the ends that allow you to be more automated. Probably also worth talking about this top cover, in a sense, as we look at it on the top of the IP, this is not necessarily typical in the way that it's executed. Oftentimes you'd have a top cover that sort of goes over and is like a skeletal sublayer, and then you have a decorative cover that goes over the top. But if you do that, on the bottom of your A-surface top cover, you don't have the opportunity to integrate and mount different features. That is something that Rivian, by virtue of the construction of their IP and by abbreviating what could have been structure up here and leaving this open, they've now left themselves real estate by which they can sort of undersurface mount several different elements here. So talking about some of the different features, actually Tesla did have on the top cover we were looking at there, their speakers in somewhat of a similar fashion. This component right here is actually a pyrotechnic disconnect for the 12-volt system. So if we can rotate there. So that little connector in there, it's kind of difficult to see, but that's a small, they call it a squib or a pyrotechnic charge. Similar types of those connectors or squibs are throughout the safety restraint system. You see them on the passenger airbag there. Those are small pyrotechnic charges that in the event of an impact, when your acceleration sensors say, hey, we're getting into a wreck, that's going to detonate and cause something to happen. So in the case of the airbag, it's causing the airbag to inflate. It's starting the sequence of inflation. With this, though, a pyrotechnic disconnect, with the 12-volt here, this is actually a part of a process of de-energizing the high voltage system. So there's a small charge in here, there's like, a link that essentially, if it gets into a scenario where it's like, I'm crashing, I want to de-energize this vehicle, it will pop, disconnect several things, it'll follow through, kind of trickle through the system and de-energize, shut the contactors off, and put the vehicle in a safe state. So a little bit interesting to see it on the underside of the IP top cover. I know Chris said that's typically like in the engine bay. I guess it could be anywhere in the vehicle, but just an example of something that you have to package somewhere, putting it in space that is otherwise not available. Kind of clever.
So normally the top pad, of course, we would have the passenger airbag.
For sure.
We may or may not have the speakers. and then we may have welded ducts. They do not have welded ducts on this, but they've managed to package all of these other components, which, as long as in their assembly process they have access to all of the connectors, sure, it's a good idea. It does make the part somewhat unstable, though.
Yeah, so we do have some debate about that. I don't know, Carl, like so we've got a lot of weight on that side. It's pretty flimsy. It's kind of a bacon strip. I don't know, like I definitely can't pick it up from this end, right, without it flopping. And if we flip it over, you can see that from us twisting and turning it, like there's a crease in here that's it's not going to come out, right? Like it's been deformed with this, which kind of brings up the question of, okay, what sequence is this going on to the IP in? Does it have the big weight of that PAB chute on there, or is that coming in after the fact? Now, I do know it's probably worth pointing out, so this, when we say PAB, it's an acronym for passenger airbag. This is often called a PAB chute. You might hear people say PAB, but passenger airbag chute. So this is vibration welded onto the top cover here, which means it's a form of adhesion whereby essentially you bring two like materials together and there's a high frequency vibration that causes the plastic to melt a little bit, and the friction and the melting causes it to hold in place. So there's no adhesive applied, but it is plastic welded, if you will, to this. And we were trying to figure out what sequence that happens in.
Yeah. So we were wondering whether we could put this in with the IP already installed. So this is a pillar clip point. We have 3 pillar clip points across this front edge. You'll see how that pillar clip point is halfway through the bolts that secure this passenger airbag. Here is that point. So in order for them to run those bolts, they would have to feed up that airbag, hook on the back edge, which has an install angle, and then run bolts up along here. I don't see that happening. It would be too complicated in their assembly. Unless they really, really made a mistake, I don't think they would do that.
Having heard you explain it like that, I think I would tend to agree. I think when we, every time we initially look at these, we start to hypothesize, think about, oh, maybe this is like this because of that. As I've heard Jordan and Kevin say, I think, we don't always know the context. We're not a part of the back discussions. I thought it was interesting that, so this vehicle doesn't have a conventional glove box, kind of polarizing. Some people like it, some people don't. I wondered if maybe it didn't have a glove box because they needed access from below to vibration weld that PAB chute onto there. But I don't know. I think that theory falls apart with the things that you're pointing out. They do have the access, but I don't know that they necessarily used it for that.
When we had this completely assembled, even with the lower portion on, I could fit my entire arm inside of this instrument panel. Normally you would never have that much free packaging space. So the carrier panel, we have all of these different A-surface trims. And now here's a debate. Most traditional OEMs will have their crosscar beam, and then they'll have this giant carrier panel that acts as a big bracket. And then all of their trim pieces attached to that bracket. Now the debate is they can change out those trim pieces over time. Say, well, we want a different style. Sure. So they would have their carrier panel, which is their bracket, and then just switch out the trims. When we took apart the Model S, they had no carrier panel. All of these panels attached directly to the crosscar beam, eliminating a component that is $250,000 or more in tooling, and then manufacturing the component itself. So here is a traditional carrier panel. This would be mounted to the crosscar beam, and then all of these trims would be mounted to it. At first, I was going to commend them for completely removing the carrier panel from the Rivian, but they didn't. They do have a small one, but it's only about that big. So they went halfway there.
Yeah. Yep. Maybe it was 2 designers. One was from Ford, which that part came off. One was from someone else. But no, it's a step in the right direction, to your point. That one that Carl just showed was off the Mach-E. It has some conventional elements, but definitely some new ones. And I think in terms of the new trend we're seeing, and very similar to what we saw on some of the Teslas we've looked at, we've also seen it on Mercedes, another L-ring Klinger hybrid style beam where you've got a hydroformed aluminum center structure, and then you've got injection molded, over molded glass filled nylon. Interesting that the center profile section on this is a little bit different than some of the section's a little taller than some of the other beams we've seen. That may have been an enabler for packaging, kind of shortening it in the fore-aft axis perhaps. It is interesting too, I think Carl's going to grab the other beam here just as a point of comparison. seems like they added a little bit more in terms of structure in the actual molded portions that came off. Like there seems to be kind of four, I guess, similar notes here. They do have one cast feature here where the Tesla Beam did not, but it's the same basic strategy, right? You've got a metal core structure that's providing the bulk of your rigidity in the crosscar direction, and then for your mounting points, you have overmolded plastic reinforced with glass that's coming out to engage with your major monuments. And you can see, yeah, top, side, side, side. Similar, same manufacturer of the beam, just a slightly different execution.
Yeah, it's a lot more structure included in this one. If you just look at the cross ribbing, the structural supports here, this is basically just tying the plastic to the plastic. There's a lot more of that within this beam than there was on the Tesla. They even have a branch that ties side to side around the air ducts that is tied into their crosscar beam. So there's quite a lot more structure there. However, I do really like the execution.
Kind of an interesting little tidbit here. We have seen this on some vehicles before. It jumps out a little bit. So you've got 4 separate ducts here for the different HVAC zones and channels for air. Kind of a low cost strategy here. They've riveted together the different sections. So it's probably an example where either from a tooling complexity perspective, they couldn't blow mold a part that had those internal partitions just based on the limitations of blow molding. So instead of choosing to make a more expensive injection molded part that had all those different ducts, they still went with 4 blow molded pieces. They just riveted them together. I think we've seen that on some Jaguar Land Rover vehicles, but it's kind of interesting there. And then as far as the ducts, something else kind of unique up on the top. We have seen it before, but this duct, like if I were to squish this, so this is actually what we would call a clamshell duct in that it's 2 pieces, but it's just foam. So in this case, you know, it's not atypical to see a hard plastic duct that has NVH pads on it or BSR provisions. In this case, it's definitely lightweight, and it sort of is resistant to BSR by itself. This isn't the first time we've seen this, but you know, it's just a different way you can execute a light, sort of low-cost duct in the IP here. So this is clamshelled foam as opposed to blow molded ducts. And I know, Carl, one thing you pointed out, kind of feels like they really were judicious in like getting the ducting done first and then sort of designing the system around.
Yeah, so if you were to be on that end of the IP and you sightline down this duct, you'll see that everything is basically in line. It's a nice, clean profile. It's exactly where they need it to be. So in my opinion, I would say that they put this first in their CAD design and then built around it. It made it a little efficient. So we have the low-cost foam duct, we have the blow-molded ends, and then we have the blow-molded connector in the middle. So we can go ahead and get another shot from the Tesla Model S. The ducts on the Tesla Model S are a welded duct, welded right to the back of the top pad substrate. However, they could not go all the way over to their air vents. So they still have a separate bolted on, blow molded, injection molded connector that goes from their welded duct into their air vent. I think that that's actually a much lower cost approach than this vibe welded large injection molded duct. For most of my customers, however, that need the structure, I readily recommend a structural duct. Welded structural duct gives you that structure without needing the carrier panel. Well, they were able to get rid of the carrier panel and get rid of that structural duct with a low-cost foam. So I think that that was probably a good idea.
Yeah. So I don't know, Carl, what do you think? Sort of tying it all together. I mean, at a top level, I think they definitely spent the money and the time, the design effort to pursue some exotic materials. It looks like they maybe got a little bit out over their skis with some of the execution where they had to make some compromises to kind of reel it back in and get it done from a manufacturing perspective. I think structurally, the L-ring Klinger beam with the plastic over the aluminum is definitely a weight-efficient way to go. We've seen more and more of that. And then they kind of like, I don't know, it seems like they were pretty forward-thinking with the placement of their HVAC ducts and you know, held sacred space for those. And we're committed to trying to be more efficient in the top and got most of the way there, but not quite, maybe.
So if you're trying to bring it together and have an answer, here would be my question.
Okay.
What are they trying to do? Are they trying to make money? With what they have built here, with this crosscar beam, with all of these wrapped components, with the wood, I do commend them on forethought on some things. Are they actually making a profit on a $74,000 vehicle if this is what they're designing throughout their vehicle? I don't know if they are. But for a high-end vehicle, I think that this fits in because I've seen some vehicles with much higher price points that I would say are not executed as well. Sure. They don't look as premium. But I don't know if Rivian is making money.
It's a good question. I guess we'll have to leave that to them to answer. But yeah, I mean, I think at the end of the day, I agree with you there. There's a difference between being cost efficient and just being manufacturable or aesthetically pleasing, and obviously everyone's trying to balance a combination of that. So interesting to see how they went about it here. Interesting to see, consider how it might evolve. I did notice, I think on this side of the IP, you can see, and this is something that you'd expect is similar. So the R1T and R1S architecturally are going to have a lot of similarities. If you look at that tag there, you can see R1T, R1S on it. That's not weird. Definitely vehicles share IPs and cross car beams across those with similar architectural hardpoints. So, for this, Rivian spent the time. They've invested. This is a major monument in the vehicle. It's unlikely that it's going to be a significant departure or change for some years, and it's going to be used in the R1T and the R1S. So, I don't know. At this point, they might be kind of constrained to this. We'll have to see over time if it continues to evolve. But yeah, I mean, for a first pass, understand some of the different things that were in here. But to your point, yeah.
Now,
are they making money?
Here's a question to you about Rivian.
Okay.
Just what you know about Rivian. Okay. In my estimation, a lot of the employees at Rivian were traditional automotive OEM employees that kind of got pirated and moved over there.
I do know a lot of people who got sniped and brought over there, yeah.
So I would say that this is a traditional automotive engineer who was allowed to do something different, but did not know how far they could go doing something different.
Sure.
So here's an example. There is a requirement in a lot of OEMs that you must have an attachment feature every 150 millimeters. Look at all of the different attachment points for different types of features across this top pad. There's a lot of them. There really, really is.
Yeah.
When we were looking at how the top pad of the Model S fit to their entire instrument panel, it was 5 screws. That was it. 5 screws and then 2 bolts for the airbag to the crosscar beam. So that is something that I end up questioning a lot of automotive companies on, is why do you have this 150 millimeter requirement for your attachment? What is that actually based off of? And someone somewhere says, oh, there was this product and it was moving, so we made that requirement, and then it just went to everything. So this amount of fasteners, I say, is a carryover from the traditional automotive people who now do have the freedom to do something different, but they haven't gotten completely there yet.
Sure, sure. And for those at home, Carl's particularly sensitive to the genesis of fastening standards because having been in a supplier role and questioned, hey, why do we need this? Oftentimes, if you really press on folks, they often can't articulate where or why the standard exists or what it's there for. And yeah, that does lead to some.
I had that issue. I had a specification from an OEM that once I branched it all out to everything that spec said, and then the reference specs that it went to, they were all crossing. So they were contradicting each other. I printed out every specification, mapped them, tagged them, highlighted all of the things that were wrong. And I asked for a invitation or a meeting to go to the OEM and speak with the person who was in charge of those specs. I put the pile on his desk and I said, now, what is real here? He didn't even look at him. He looked at the pile, then looked at me and goes, I don't know. I was like, oh, great. So they make all of these specifications that their own people don't even know. The supplier, they put on the paperwork that says you need to follow them, but you don't actually follow them. You violate them, and they purposely close their eyes and ears until they have a problem. Then blame the supplier. All right.
That's fair. And I would say, and I know we're kind of probably going to be wrapping up here soon, but that is one of the things too, when we talk about OEMs, like startup OEMs and advantages they may or may not have, one of the advantages is double-edged sword, like they don't know what they don't know, right? The standards, the baggage, the legacy sort of dead weight of some of those things, they don't have them. So it might not prevent them from making something wrong, but it also will prevent them from, you know, designing things inefficiently for standards that they can't articulate. So I don't know.
Well, in general, I think this is a good first step for this vehicle. There's some very interesting things. Some are probably a little overkill, but we'll see how far as we get more into the Rivian and more of the internals. We can see in general how we think these designers did that. So thank you very much for watching Monroe Live. I hope that you will subscribe if you're not already subscribed, and stay tuned for the next videos.
Thanks, everyone.